Alrighty, hello everybody and welcome to the live wolfSSL webinar on libcurl with curl founder and maintainer Daniel Stenberg. My name is Kajal Subkota and I will be moderating this webinar. All attendees will be in listen-only mode. If you have questions, please use the Q&A box or raise your hand to be unmuted if you would like to ask the question live, as we do host a Q&A box session following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. And I invite you to follow us on Twitter at wolfSSL, as well as all of our other socials. And please feel free to email us at facts@wolfssl.com if you have any additional questions. And now I'd like to give a brief company overview before we move to the technical presentation. wolfSSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized there wasn't an open source dual licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, and was equipped with a clean and modern API, and offered commercial style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 40 dedicated employees in 2020, most of which are engineers. This process is, of course, supported by a strong partner network that we're proud of, which includes NXP, STMicro, and Microsoft, for example. Since the beginning, our engineering team has developed several embedded security products, including WolfCrypt with DO178 support, FIPS certification and a FIPS-ready offering, MQTT up to the version 5 specification, SSH-v2, TPM 2.0, a secure bootloader known as wolfboot, as well as Java wrappers and JSSC support, and commercial support for curl. All of these offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'm going to hand it over to Daniel for the presentation.
Thank you. Okay, let's get started here. So tinycURL, yeah, and I'm Daniel Stenberg. I do curl full time. I do commercial support and I'm maintaining curl since 23 years back. And as you understand now, I work for and with wolfSSL. So today I'm going to try to keep this fairly short and sort of to the point, but I'm going to first take a short recap what curl is, and just to get an overview for this, and that it's everywhere, a little bit about the API, what the ordinary vanilla libcurl has in comparison with tinycURL, and I'm going to dive into details about tinycURL, what it is and why and how it works, and mention something about support of it, and then a little bit about the future. And of course, if you have any questions, as just mentioned, submit the question using this little Q&A thing here in Zoom, and we'll get to that in the end. Or you can ask the questions in the end as well. So as you know, or you should know maybe, curl is an open source project, and we make two things. We make a command line tool and a library and for transferring data using the popular internet protocols. And of course, HTTP and HTTPS are the most popular and known ones. And today I'm going to completely focus on the library part, the libcurl area of this. Let's ignore the command line tool for today. libcurl, and well, I call it curl, but in reality it's libcurl. It really runs in all your devices, or in a lot of your devices at least. It is in cars, TVs, computers, game consoles, servers, kitchen utensils, utilities, or watches, and these set-top boxes, games, and a lot of mobile apps. This keyboard on the top of the screen also runs curl. So it's really in a lot of places. We estimate that it's in at least 10 billion installations worldwide by now. One of the world's most widely used software components, no doubt. It has been reported to have run on these 86 different operating systems and on these 22 different CPU architectures. So it's literally available on pretty much anything you can imagine, or it can run on it, or should at least. And all of that while maintaining a single unified API on all these platforms. You can run the same application written for the same API on all of these platforms. curl has really developed to become in this Swiss Army knife of internet transfers and HTTP in particular. Here's just a very tiny example of a application that uses libcurl to transfer data. This is then getting an HTTPS URL. It retrieves it down to the local computer, and in this case, it just outputs what it gets to the terminal or standard out. So it's maybe not the most practical example, but it's short and sweet, and it shows how you could do it. And this, as I mentioned before, this same application can run exactly like this on almost all of these platforms. Of course, you might want to take care of the output in different ways, because not all systems you have a standard out or a terminal to show the output on. But otherwise, this exact code can run on all those 86 different operating systems. So this is then done well, up until now, basically, we've shipped and provided a vanilla libcurl. That's the regular libcurl, right? It's feature packed and full-fledged, and it's made for real operating systems, or real, I should say, ordinary sized, and it provides a lot of protocols, libcurl that is, and even many versions of several of the protocols and a lot of features. It's literally packed with features and different options to do a lot of different kinds of operations, and you can tweak and twist how exactly you want things to happen. You can also build libcurl to use a lot of different third-party dependencies. The total amount you can use is up to 36 different direct dependencies, I believe. Not that it's possible to actually use all those 36 in a single build, but still, there are a lot of options. And all this taken together, if you look at the curl as built, I did this little experiment the other day that I checked on a Debian Linux machine. I checked the regularly installed curl binary just on the current Debian unstable distribution on an x86 64-bit. So that curl binary uses 34 different shared libraries at a total size of, well, around 15 megabytes. And of course, that is pretty much then libcurl and all its dependencies and sub-dependencies, because some dependencies uses dependencies on their own, right? So it's pretty much a tree of dependencies. So 15 megabyte for give or take for one build of libcurl on one of these big operating systems. Pretty much all features enabled, all protocols. But we're, of course, 15 megabytes is a lot of megabytes for systems that maybe just have a few megabytes in total to store data, maybe just a few megabytes of RAM. So we're introducing and working on tinycURL instead. And in order to get to tinycURL, we make it do a little less. So we disable all protocols by default, except HTTP and HTTPS. We disable a lot of features that we think most users on tiny platforms won't use, or probably rather go for a smaller size rather than have a lot of fancy features. And we're focused on getting HTTP GET support for HTTP 1.1 and TLS 1.3. So HTTPS GET, really, yes. we're using wolfSSL TLS library by default for reasons, of course, because it's pretty much the smallest one that has all the features we want, and it's of course a wolfSSL product, so it goes really well for this. And we also add support for additional real-time operating systems that we don't have in the vanilla curl distribution. And I'll get back to exactly how this works. And thanks to us doing those choices, tinycURL is smaller, and it can actually be a lot smaller than what I showed you, the real vanilla libcurl. So our ambition here is to make sure that you can build libcurl with a TLS library with a size on disk that is within 100 kilobytes. And I mentioned that 15 megabytes before, and how we're talking 100 kilobytes. So it's a factor to 150. And of course, this is because we've excluded all dependencies except the TLS library, and we've switched off a lot of features. And the RAM requirements, the memory requirements here is just roughly 20 kilobytes that curl uses. Of course, when curl uses other, like when it sets up TLS also uses some memory. So it's actually in total it'll use more than 20, but curl itself uses 20. So that's I'm measuring that because that's what we are in control of, really. And compared to a regular vanilla libcurl, that is also, it is much smaller, but the biggest size gain is by really limiting the download buffer sizes, and you can do that with a regular libcurl too. And I mentioned we are doing some extra additional ports to other operating systems in the tinycURL effort, and we're so far we have free RTOS and Micrium support in it, and we're going to, well, I'm in the process of getting QNX support landed in there, so there will be more and more real-time operating systems supported in the tinycURL package as we go forward. And of course, if you have a particular one in mind and you want to get tinycURL going on your particular platform with that, the tiny portion in mind, so just get in touch and we could prioritize that and get that going, because getting curl on another operating system is not that hard, at least not for us engineers here. So curl as a project comes with a lot of features, and a lot of them, and more actually going forward, are possible to disable at build time. So when you build curl, you decide if you want to have these different features enabled or disabled. And here are roughly, what is this? Is 19 features actually, 19 features that they're all disabled by default when you build on tinycURL. So none of these are in there because we consider them probably, maybe not niche, but maybe at least somewhat special, and maybe your tiny devices don't need these, so you can build tinycURL without them. And of course, that makes the sizes shrink, both memory requirements and on disk storage, because less code and less data to handle all that. Going forward, I'm sure we will continue to make sure that we can disable, for example, when we introduce new features that maybe are big in size, we introduce this ability to disable them to make sure that we can maintain a small tinycURL even going forward, even when we add new fancy features into libcurl. But just because I've now mentioned those 2019 different features that we disable by default, it doesn't mean that you have to have them disabled, because all these features are enableable on a individual basis, basically one by one. So you can actually, if you want one of those in your tinycURL build, you can actually enable it. So you don't have to have all of them disabled. But of course, if you enable one of these, you will get a slightly, of course, larger one. So that pretty much goes for this, as you can then select exactly what features you want, and you can add more and more, and it'll of course grow in size if you add more features. So I'm going to, so there's a question about license and the statically linked, but I'm going to get into the license questions in a second. Just hang on with 1 second more. So we do this, so the ability then to get, let me back it up. So getting one, there are some really big benefits in having curl as the tinycURL version of the libcurl offering, and that is of course because that libcurl is very well known among developers. It's a familiar API. A lot of people have already used it, and it's remained the same thing, the same API and the same platform for a long time, and it's very well tested, and the same code runs on a lot of platforms, so we can verify this and test it nonstop all the time. So when you go with libcurl, you know that it's fairly stable and solid, and it's very well documented. It's the same API everywhere, so if you used it before on another platform, going to a new platform is, you don't have to learn a new API or anything. And another good thing is that we've had this same API for 2 decades now, so we've had time to polish the APIs and the examples, so they're there. We work hard on security, and it's really battle hardened. You know that this actually a library that works with the real servers out there, because it's used, as I mentioned, 10 billion installations. Everyone already uses this, so you can too. And we don't modify behavior. We have a stable API that we don't shake. So it's, it's the same API. Examples we built in the year 2000, you can still build those examples and run them today. It works the same way. We have new features now, you can do more, but the old stuff still works. And this way, you really truly avoid the platform lock-in. For example, you don't get stuck on a particular vendor's operating system or solutions or anything. By doing this, by using libcurl, you know that you can bring your code over to the next platform easily and immediately without having any second thoughts, because it's the same API on the other platforms as well. So you really, you need to, and this allows you to avoid your OS vendors HTTPC examples. I see a lot of customers and users who want this really small HTTP client to go with one of those example source codes that most operating system vendors ship with their development boards, for example, but they're usually really, really horrible. And the HTTP is actually harder than it looks. And there are a lot of pitfalls that you can avoid and you should avoid by going with a trusted, well-tested used library, or sort of something that's been out there for a while. So about the question of licensing. So tinycURL comes GPL v3 licensed, or dual license as a commercial license. So this is different than the regular curl package, because we ship the regular curl as MIT licensed only and tinycURL as GPL v3. And we do this to make sure, or rather encourage people to either go the free software open source route, or you consider licensing it commercially from us at wolfSSL, to allow us to actually continue this venture in improving curl even further for these platforms. And of course, when you buy a commercial support from us at wolfSSL, you pretty much get it supported by me. And by me, I mean Daniel. I know curl a little bit. We have this ambition to do tinycURL releases roughly twice per year. And when we do it based on the latest curl, and we more or less apply the tinycURL magic, and we ship it. I'm a little bit behind on the current tinycURL release because of, well, I've been a little bit lazy, but my ambition is to do the Q and export and get a tinycURL release out soon. And of course, we can do them on request, or if you have any sort of particular ideas or thoughts around it, we can, of course, discuss it, and we can do anything. And in the curl repository on GitHub, you can find the tinycurl code in dedicated branches. So I do branches for every release. I didn't do that for the earliest ones, but I did it for the recent one, and I'm going to do it for the ones going forward, of course. And the question was also about, so I clicked it away. The question I got was also about if it can be statically linked. And yes, if you build it for FreeRTOS, I think, I don't remember exactly, but I think that's pretty much the only option. Then you will get it statically linked. So if you're going with a FreeRTOS solution, you either go with the completely open source route, or you're going with a commercially licensed version, I would imagine. And okay, so we're not completely done with tinycurl, of course. And as I said, we're going to make sure that we do releases based on the regular mainstream curl, and that is going to continue to develop. So we're going to continue to do tinycurl releases just because of that, if nothing else. So we will do these regular sync up releases, so we keep up with the real regular curl, so we get all the bug fixes and all the improvements and security fixes and stuff like that. And there will be more support for additional real-time operating systems going forward. I mentioned 2 already supported. We're going to add a 3rd, and I'm sure, and with guidance and the request, we're going to do more going forward. There is more work to allow more customizing, so that we can enable more features to really squeeze off even more data that we don't use for particular tinycurl installations, and perhaps even add more features that are more targeted for the tiny devices. And we're going to make it even tinier. There is more work, and I have ideas what to do to cut off more stuff that isn't used in the tinycurl installations, or make sure that when you switch off features, there is more to switch off for each feature, and so on. So there's more work. So your input and your ideas, of course, will help me and us guide the future here. So the future is not set in any way. It'll be more tinycurl, and it'll be fun, but exactly how, we don't really know right now. So if you want to figure out even more about tinycurl, there's this. I have a web page on the curl website on curl.se/tiny. You can go there and see it, but that's basically says just a little bit, and the rest of it I've told you on this presentation. And then you can go to the wolfSSL site and read about our curl support in general, or just email us at support@wolfSSL.com, and we'll help you out with whatever curl solution you want. And as you might have understood, tinycurl is just a flavor of the regular curl. So maybe you don't even want a tinycurl, maybe you even want the support for the regular curl. Everything is there. So that's pretty much what I wanted to say, short and sweet. I'm at 20 minutes something. Anything I forgot? Any questions? Shoot.
Yeah, as a reminder, everyone can use the Q&A box or the chat box, or you can also raise your hand if you'd like to be unmuted and, ask the question live. I've got a question here. Which library or toolkit does curl use for unit tests?
Good question. We don't use any toolkit or library. We have our own in-house built unit test suite. So our own, I would say.
Awesome. We'll wait a couple more minutes.
I could add that just since curl is C code, it's a unit test suite is usually very narrow and limited, so it's actually pretty easy to write your own.
We'll wait a couple of minutes. While we're waiting, does curl do tests with older or old versions of wolfSSL like 3.6 to test specific behaviors?
No, not regularly. We regularly only test with wolfSSL of a single specific version, and we hope that that covers the wolfSSL test pretty much. So we run the entire test suite with curl built with wolfSSL of a specific version, which I think right now is 4.6 or 4.7 is the latest, right? I don't remember exactly, but we pick one and we stick with it for a while until we bump up to the next one.
Are you currently using fuzzing tools to test the security of curl?
Yes, we do. We do a lot of fuzzing actually. So the primary part of our fuzzing is done with the OSS Fuzz project, which is a Google fuzzing project that they run fuzzing nonstop on curl code. So we have pretty much done a little adaptation that makes sure that they run their code and they can fuzz curl all the time. And part of that system, there's also an integration with the OSS Fuzz project called CI Fuzz that makes use of the OSS Fuzz infrastructure for a short while for every commit and pull request, so that we actually fuzz a little bit before we merge code to just make sure that we at least haven't screwed up royally. So the fuzzing, the OSS fuzzing is actually a pretty good system, and it works really good.
Okay, awesome. If we're using libcurl with OpenSSL, will the compatibility layer allow us to use the OpenSSL path of libcurl, or do we need to move our extra logging into libcurl's wolf module?
I don't quite understand. I don't understand the question really. So is the question if you could build tinycURL with OpenSSL?
I think they're asking if they're using libcurl with OpenSSL currently, would the OpenSSL compatibility layer that wolfSSL has allow them to continue using libcurl through OpenSSL, I guess, or would they need to move the libcurl to the wolf module, or to like libcurl's wolf module?
I don't think I quite understand the question, but I think I could answer perhaps more generically and say yes, wolfSSL has an OpenSSL API, but when you build libcurl to use wolfSSL, we try to avoid that. So we usually access wolfSSL directly without using that API. So I'm not sure exactly if you want to go with wolfSSL, we support that directly with wolfSSL API. But if you want to use wolfSSL, it's better to use the wolfSSL adaptions we have.
Yeah, of course. I think those are the last of our questions. If you have any more questions, please feel free to email us at facts@wolfSSL.com. If you would also like to receive a copy of the slide deck, you can also request for it at facts@wolfSSL.com, and we'd be happy to send you. And as a reminder, this webinar is recorded and will be made available via our YouTube channel shortly following the presentation. And as a reminder to everyone, please follow us on all of our socials at wolfSSL.com. And thank you so much for the fantastic presentation, Daniel. And I hope everyone has a great day.
Bye.
Bye.